Let's take a look at some examples. And the first one, it's asking us to evaluate 7 to the 0. And so if we refer back to our properties of exponents, one of them, the zero exponent rule, says that any non-zero number to the 0 power is equal to 1. And so the same is true here. Number 2, 7 squared, 7 to the second. So that's 7 times 7, or 49. That's just squaring a number. But 3, negative 7 to the second. So this is a little bit different because of where the negative is placed. We want to always be sure what this is asking us to do and use the order of operations appropriately. So we're actually squaring negative 7 in this case, and that's negative 7 times negative 7, or positive 49. Okay, now 7 to the negative second, using the negative exponent rule, that is the same thing as 1 over 7 to the positive second. Or 1 over 49. Okay, and then negative 7 to the negative second, using the same rule, that's 1 over negative 7 to the positive second, or 1 over 49, same answer. 1/7 to the negative second. Okay, 1/7 to the negative second, we have a couple of things happening. So we have this fraction, so we could use the power of a quotient rule, and we have a negative exponent. And so you could think about it as raising 1 to the negative second, and also 7 to the negative second. But these negative exponents are really just going to flip this fraction, and so that becomes 7 to the second in the numerator, and 1 to the second in the denominator, or 49 over 1, just 49. The other way is to just take the negative into account, the negative exponent into account first, and then flip this fraction, take the reciprocal, and you just get 7 to the second, and that is also 49. Okay, and then this last one, negative 7 to the negative second. So many negatives. Okay, so first I want to take this negative on the outside of the parentheses into account, that I want to just kind of keep it to the side for now. Negative 7 to the negative second, we already evaluated that earlier. So that was 1 over 49, because it was 1 over negative 7 to the positive second. So negative 1 over 49. And then don't forget that negative, the very first negative, changes the sign of whatever your answer was. So the final answer is negative 1/49. And let's take a look at another example, and this one is working with variables as the bases. So a to the negative second to the third times a to the fourth to the negative third over a to the 12th. What our goal is to find an answer that involves, it's in simplest form, it involves only positive exponents. Okay, so to do that, we're first just going to use the power rule and raise these powers to another power. And we get a to the negative second to the third is a to the negative 2 times 3, or a to the negative 6. And then a to the fourth to the negative third is a to the negative 12th. And then divide by a to the 12th. Okay, and now it's really kind of tempting to cancel out these a to the negative 12th and a to the 12th, but they're not the same thing. If they were identical, then you could. And so the next step that I will choose is to go ahead and use the product rule in the numerator. So a to the negative 6 times a to the negative 12 is a to the, add those exponents together, and you get a to the negative 18th over a to the 12th. And then at this point, we can use the quotient rule, so subtract those exponents. So we get a to the negative 18 minus 12, or a to the negative 30th. Well, the last step is to ensure we are only using positive exponents in our answer. So use the negative exponent rule to say that the answer is actually 1 over a to the positive 30th. And the last thing that we will take a look at in this section is to convert between scientific and decimal notation. And so decimal notation is how we typically write our numbers. However, sometimes if a number is so large or so small or very close to 0, it's much more convenient to write a product involving a power of 10. And so an example of scientific notation would be 4.0 times 10 to the 6th. And that would be 4 with 6 zeros after it, or 4 million. Okay, now notice in scientific notation, we always have this number that's called the mantissa, and there's always one non-zero digit to the left of the decimal place, and then multiplied by a power of 10. So 35 million. Okay, well, I know 35 million, if I'm going to write it in scientific notation, first, I'm just going to think about what 35 million actually means. And so that's 35 times 10 to the 6th, because there would be 6 zeros. However, that's not in scientific notation because the decimal is not in the right place. That's the same thing as 35.0, but I really need 3.5. So I have to somehow get it to be in the correct notation, which is to convert the mantissa, which then also changes the power of 10. So 3.5 times 10 to the 1st would get us back to 35, and then multiply, bring down that 10 to the 6th. And altogether, this answer is 3.5 times 10 to the 7th, because you're going to add the 1 and the 6 together. Okay, now you can verify that you've done this correctly, because what this 7th power is telling me is to move the decimal 7 spots to the right. So 3.5, if I move it 7 spots to the right, inserting zeros where there are none. We end up with 35 million. Okay, and then number 2, the last example, is convert 0.014 to scientific notation. So in this case, this mantissa is going to come right after the very first non-zero digit, which is the 1. So 1.4 times 10 to some power. And well, we just saw how raising to a positive exponent, raising 10 to a positive exponent, is going to make the number larger. But if I raise to a negative exponent, it's going to make the number smaller. And so remember, 10 to the negative 1st, for example, is 1 over 10 to the 1st, or 0.1. And that's kind of what we're thinking about in this scenario. So 1.4 times 10 to the, we determine whatever the exponent is by how many spaces we have to move this decimal to get it back to the initial number. Okay, and that would be 1, 2 spaces. And that's going to make our exponent negative 2. So 1.4 times 10 to the negative 2nd. Now if you think about what we just did, and how this relates to our properties of exponents, that's 1.4 times 10 to the negative second is 1 over 10 to the second, or 1.4 divided by 100. And what do you do when you divide by 100? You move the decimal 2 spaces to the left, and we would end up with 0.014.